evil twin. The Nemesis theory describes how our sun was born alongside an object which later developed into a dwarf star, and that this star later became responsible for many of the mass extinctions which occurred here on planet Earth. The theory was first developed in the 1980s, when scientists were attempting to explain why Earth's extinctions seemed to take place in a predictable cycle. Massive extinctions were seen to have been inflicted upon our planet roughly every 27 million years. And since there's no great force on Earth which should have caused such ecological calamity, the scientists instead looked to the stars for an answer. One of the theories developed was the notion that our sun had an evil twin called Nemesis, which was so named because it had the habit of hurling devastating asteroids towards our corner of the galaxy. Those of us with brothers and sisters know all too well how annoying they can be at times, but I'd wager a few of us have experienced the sheer terror of knowing your sibling wants nothing more than to pulverize you with giant space rocks. If you have experienced this, please write in and let us know. Over the next few decades, scientists tried to identify potential candidates for Nemesis, with Berkeley University's Richard Muller suggesting it could exist in the form of a red dwarf star 1.5 light-years away. Others argue in favor of it being a white or a brown dwarf. Either way, it was speculated that Nemesis's presence may affect our solar system's asteroid belts, with the transition of this unknown object sending huge balls of rock towards our world whenever it passed near to or through them. The Oort cloud exists on the outer fringes of our solar system, and there's another asteroid belt which sits between Mars and Jupiter. A large enough body could feasibly cause these bands of icy rocks to change course, and the theory that this is caused by a large, dimly lit star is backed up by the unusual presence of the dwarf planet Sedna. Sedna orbits the Sun at a distance 3 times that of Neptune, and nobody's quite sure why this small world, which is smaller than Pluto, hasn't been dragged closer towards the Sun during its lifetime. The existence of a large dim star on the periphery of our solar system could explain why. But in recent years, other theories, such as the missing planet 9, have come to replace the Nemesis as an explanation for disrupted asteroid belts and the odd trajectory of Sedna. However, in mid-2017, research conducted at Berkeley seemed to back up Richard Muller's theory 3 decades after he'd suggested it, as computer models of star formations seemed to prove that almost every star is born alongside one or more others. This research took the form of an investigation into the Perseus cloud, 600 light-years away, with researchers identifying 19 binary star systems and 45 single star systems within. It was discovered that most of the binary star systems which were far consisted of young stars, whereas those which were older tended to group closer together. The only simulation which explained how this might happen showed the vast majority of stars forming as part of a binary system, with 60% splitting to form 2 separate star systems, and the rest drifting together to form one tight binary system. This discovery means that it's incredibly likely our Sun was born with a twin, albeit not 100% certain, with some scientists contending ours is one of the few stars to have been born an only child. And even if we are a twin, we still don't know whether our sibling exists many hundreds of light-years away, or if it sits on the edge of our solar system as a dim dwarf star. If the former is true, then there's a chance this star's solar system may have formed as ours did, with life potentially existing on the planets in orbit around it. But if this star exists on the edge of our solar system today, then it almost certainly does not hold any life-harboring planets. Instead, this star has committed itself to an opposite function: a systematic and routine destruction of life on Earth every 27 million years. Well, ain't that just family for you?